So a fire truck can get 12 feet from the base of a burning building. The extension ladder is used to reach the upper floors. Why don't we want it to get any closer? In case the building falls. We don't want it to fall on the truck, okay? Because the ladder can be extended to various lengths, it can reach higher and higher up the side of the building. Answer the questions below to describe the relationship between these two quantities. If the ladder is extended to a length of 13 feet, then how far above the truck can the ladder reach on the building? So we're saying the ladder can extend to a length of 13 feet. And we know the truck can get 12 feet from the building. So how far up the building can the ladder reach? You were saying a second ago, what kind of formula were we going to have to deal with when we talk about triangles? Pythagorean theorem. Okay? So if we use Pythagorean theorem to solve this, let's call this x instead of question mark. That's just more common for us to use in math. Yes? Okay? So if we call that an x, what kind of equation are we going to set up to solve here? Perfect. X squared plus 12 squared equals 13 squared. Okay? So in order to solve this, I've got to know 12 squared and I've got to know 13 squared, don't I? Well, hopefully we know 12 squared is 144. And hopefully we know, and if we don't, we can figure out that 13 squared is 169, right? So how do I solve for x? Yes, correct. Subtract 144 from each side. So x squared equals 25. So how do I solve for x? Square root both sides. Very good. X equals 5. So tell me in a sentence the answer to this question. Here's how you started. The distance that, keep going. The distance that the ladder, yes, is 5 feet. So we need to make sure we write as much as we need to understand what's going on. Okay, very good. So what about this? The height can be what height can be reached above the truck if the ladder is extended to a length of 15 feet? How is this different from the first problem? The length of the ladder is still 15, so this is 15. What's this? 12. So we're still trying to figure out how high up the building can it go, right? Do we do it any different than number 1? So we should have x squared, because that's what we called the height above the building, plus 12 squared equals 15 squared. So x equals 100, not equals, how about plus? X plus 144 equals, do you know what 15 squared is? 225, good. Did you know it or did you check? Good. So we subtract 144 just like we did in the last problem to get x squared equals 81. So we square root both sides and x equals 9. 9 what? 9 feet. In this problem, let x be the length in feet which the ladder is extended. So x is going to be the length of the ladder. So it's going to be a different place than what we just dealt with, isn't it? Okay? X is the length of the ladder, and y is the height in feet up the building. Complete the table and the graph of this relationship. So I've already done 12. No, I haven't done 12, have I? I've done 13. 13 is 5 and 15 is 9. Okay. So what do you think? Let's fill in the rest of the table, right? I wish there was some sort of equation that we could use. There is, isn't there? We've been using it the whole time. Okay, the Pythagorean theorem. But look what I've done every time. I've taken the length of the ladder squared and subtracted the length from the building, right? So it's going to still stay 12 feet from the building. So if I square this number and subtract the length of the ladder squared, so subtract 144, I should get my y squared, so then I just have to take the square root of it, right? So 144, that's what this is squared, minus the length of the ladder squared, which is 144, equals, wait, 0? Does that even make sense? So if the length of the ladder is 12, and I can only get 12 feet from the building, it looks like that picture I drew on the board, isn't it? Yeah. Can you climb up that ladder? No, you're just walking across it, right? Okay, so it can go 0 feet up the building. Does that make sense? Okay. 13 feet we already figured out was 5. A 15-foot ladder we already figured out was 9. So what about a 20-foot ladder? What's 20 squared? Subtract 144. So square root that number, and what do you get? 16. Very good. What about 25? What's 25 squared? 25 is, yeah. Yeah, what did you get for 25? And square root it. What did you get? 21.9 is perfectly correct. Yeah, absolutely. What about 30? So 27.5 is 27.49. And then what about 37? 35. Okay, so let's graph that. 12. Wait, how are we counting here? Can you tell? By 2s, so 12 would be right here. That's 0. 13 would be right here, and that's already at 5. 15, right here, that would be 9. So that's like, oh, right here. 20 would be 16. So it's right above 15. 25 would be in the middle, so that would be 21.9. There's 20. So it's almost 22, right? Maybe right there. 30, 27.5, so like a little bit halfway in between. And 37, right here, is 35. Now, if we wanted an exact graph, we could totally put this into our lists and spreadsheets, couldn't we? And use then start a new page in our data and statistics to get an equation for it, or even look at the graph for that matter. But that's what it looks like, doesn't it? Okay. Any questions about this so far? A function to model this relationship is here. But that makes sense, right? Because we took the length squared and then subtracted 144 and then took the square root of it, right? So where does that function come from? Pythagorean theorem. So if we want to graph this in our calculator, we need to change our window. Okay? We need to change our window, so we want to start a new page that is a graph. And we want to use the window settings. What window settings do you want to use? We got to figure it out, right? Okay. Well, what kind of x values did we use over here? And here's a hint. Guys, anytime they give you a graph and you have to graph it and then they ask you to use the calculator, it's probably a good idea to look at the axes here and see which numbers they used, right? So on our window, menu window, we're going to choose the settings. What kind of x minimum do you think we ought to have? 0. What kind of x maximum do you think we ought to have? How about 50? What kind of, how do you want to count? How did they count? By 2s? What about a y minimum? How low does the y-axis go? To 0, good. And what about the y maximum? 50 was probably okay. And how do you want it to count this time? By 5s? Okay. Whoops. Okay so far? So what goes into the equation? Yeah, that one, right? So let's get the square root. X squared minus 144. So how does ours compare with what we drew? Wow, we are amazing, aren't we? Let me write this down real quick. We went from 0 to 50, didn't we? We counted by 2s, and then we went from 0. Did we go to 50 again? And we counted by 5s. Okay. Go to the table. How do we go to the table again? Control T takes us to the table. Uh-oh. I've broken my calculator. Is yours broken too? Then maybe it's not broken. Maybe we got to figure out what it's saying. What is the x value again? It's the length of the ladder. If my ladder is, it's asking me to look at 5, 6, 7, and 8. So if my ladder is 5 foot long, tell me about what's happening at the fire. The ladder is not touching the building, is it? Even if I stretch it out as far as it can go, if it's only 5 feet long, I'm already 12 feet away from the building. Okay? So my table looks like this. ERR, ERR, ERR. It's actually hashtag ERR, right? Just teasing. That was yesterday. Okay, sorry about that. Okay? I could flash back from Friday and go to hashtag Thursday. Okay, thank you. Thank you for that. So what does it mean in the context of the problem? What did you say? The ladder. How about if I spell ladder correctly? Is that okay with you guys? The ladder will not reach the building. What does it mean in terms of the numbers? Let's choose 6. That's a nice number. If I put 6 in here, what's 6 squared? What's 36 minus 144? Negative? What happens when we try to take the square root of a negative number? You can't. We get imaginary numbers, right? We don't need imaginary numbers at a fire. So you get a negative number under the radical. So what do you think the domain is of this equation? Remember what domain is? The x values. So if I look at my x values, I'm going to go back to my table's not there, okay? So I'm going to click on my graph and hit Control T. Remember that? So all I have is the graph. What do you think my domain is? What x values really are helpful here? How far to the left does this graph go? To 12. How far to the right does it go? So all the way, so how do we write that? X is greater than, just greater than 12? Or equal to 12. What happens again if it's 12? The ladder just barely touches the building, right? It doesn't help me climb up the building at all, but I can still reach the building. Okay? So what's the range? How far down does it go? And how far up does it go? So how do I write that? Y is greater than or equal to 0. So, yes, I agree with that. If the ladder's on the truck, it would be a few feet up. And that's a good thought. But let's kind of stay in the pretend mathematical context of the problem and not realistic. Sometimes even in realistic problems, we can't even get all the way realistic like we want to. Okay? But that would be, Justin, that would be a transformation, wouldn't it? Guess what we're going to talk about on Monday? Transformations. How do the numerical domain and range relate to the original word problem? And that's what we were talking about as we went, right? The 12-foot ladder would... So if the ladder is 12 feet or more, then it can reach the building. Guys, have a great weekend, okay?